There are problems with vector analysis as we use it today. It's time-consuming. It has too much repetitive math. The vectors are confusing to understand. The answers that we've calculated are not reliable. And how do you prove this to someone else when you're not sure that you understand? With PowerTools, this vector analysis is no longer time-consuming because all the math, all the drawing is done virtually instantaneously as you enter it, such as 120 volts at 0 degrees is instantly drawn. If our second voltage is, say, 60 volts at 0 degrees, you'll see it's right on top of it and exactly half the length. Okay, let's come back here. Let's make this 120 and 120. Okay, now we have our three potentials. Notice that they are color-coded: red, green, blue. That's A, B, and C, just like the color code up here. Now, as soon as we enter a current for any of these, it's going to start calculating kW, kVA, kVAR, and power factor. Let's start the first one at 7 amps, and let's put it at 12 degrees. And it says that the kW is 0.82, 820 watts. You want to see that? Well, let's put this right up here, and we know, okay, that we're looking at 120 volts times 7 amps times 12 degrees, the cosine, and that equals 821 watts. Now we show 0.82 kW. Is that the same? Yes, of course it is. We also go ahead and figure kVA and kVAR at the same time and show you your power factor is 97.81%. Alright, let's do the next one. Let's say this one is 5 amps at 126 degrees. It'll look like that. Now the total kW with both A and B is now 1.42 kW. And our last one, we'll do it 9 amps, and we'll do it at 265. Now, our overall power factor is 96.06%. kVAR is 0.69. kVA 2.5. kW 2.4. Now, by standardizing, we've ended the confusing part. The answers are reliable. They're as reliable as the information put in. Hard to prove to others? Not at all.